Hi, I'm Hassan, the lecturer here at the Institute of Medical Education, and today we're going to take a look at solutions to Section 3 of of ACER's GAMSAT Green Booklet, Practice Test 1, specifically Unit 7, questions 20 to 26. Now, this unit, it might look like a lot of information to read in the GAMSAT. However, it's not that much actually. If you know a lot about paper chromatography, you probably could just skip it, to be honest, because all it's telling you is how to figure out RF values and the different solvents they used in this experiment for amino acids. So that whole page, or whatever it was, page and a bit of information can actually be summarized in these 4 points here, which I've written them below. So when you address this unit, it's important to understand what RF equals. So it's the distance that the compound travels, in the paper, divided by the distance that the solvent travels in the paper. So when calculating RF in this stimulus, just remember that compounds in solvent S, they're the ones that were going upwards or northward. They'll always divide by 15 centimeters. So keep that in mind. Compounds in solvent T, they're the ones traveling east. I hope it translates here in the mirror image of the recording. But if they're traveling to the right or east, they'll always divide by 12 centimeters. So that's important to note here. If you can associate S with 15, T with 12, halfway there and you'll get all the answers correct. And it's important to note here that, conceptualize it here, I've got it drawn here in this figure, in figure 1, about how paper chromatography separates mixtures based on their solubility in a given solvent. Just keep in mind that if let's say a compound or a molecule is in the solvent, if the solvent travels a far distance and you find that compound at a far distance as well, it means that the compound is highly soluble in the solvent, which means it has a greater affinity for that solvent than the paper. Because think about it, if it travels far, it means it's in the solvent and it's traveling. If it doesn't go anywhere, then obviously the molecule or the item or the compound doesn't have an affinity for that solvent. It's not soluble in the solvent. It's not going to go anywhere. So if we take a look here at this pretty little diagram that I drew of paper chromatography, we can see that if we place our paper chromatograph, can't say that correctly, if we place it into the solvent with our sample, over time, the sample separates into different, let's say in this example, amino acids. And we have our solvent front at the top. And that's what we're going to measure, as in this instance, we've got here, for example, solvent S is, say, 15 centimeters. So we can see here that we've separated it by their different sizes, I guess, of the amino acids. But this is where, in this unit, we've separated it by the solubility in the solvent, not necessarily the sizes. But this is where it gets interesting, because in this unit, what they did was they turned this paper. So they turned this paper around, and now they did the same process, but instead of going up, it's going this way now. And the reason why we did that was because sometimes, if I just get rid of this here, sometimes you can say that this dot, you might think it represents one amino acid. That's not true. It could represent 5 amino acids. They might all have the same migratory distance in the solvent. So that's why we included another solvent, so we can separate the other amino acids. So that's what this whole unit is about. Just trying to wrap your head around, in this instance, we've got S is going north, T is going east to the right, and we've got our amino acids, and we're going to measure. So remember, S is 15 centimeters, and T, so it's going to go up here. That's the 15 centimeters, sorry. And our T is going to be the 12 centimeters if we put it here. If you think about it, turn your head around, you can see if it's going upward, it's 12. Go that way, it's 15. So if we take a look at the first question, question 20. Sorry, I'll just clear screen. So question 20 states, so the RF value of cysteine. So what is the RF value of cysteine? So if we take a look at the, so it wants us to find the RF value for both solvent S and solvent T. So if we take a look at cysteine, remember, if we're going to trace on the the paper chromatograph, you want to call it that, on the, let's just call it a paper, I can't say it correctly. So if we're going to trace it, we have to find cysteine. You can see if we go upwards, it's going to be S, so it's going to be 6 centimeters upwards. And our T, if we go across, is going to be 1, 2, 3. So it's going to be 3 centimeters. But remember, S, 15, T, 12. So 15, 12. So you know straight away that's going to equal, so 3 divided by 12 is going to, it's a quarter, 0.25, and 6 divided by 15, it's, well, 3, 6, that's 3, 6, so 3, 6, 9, 12, 15, so 3, 6, so it's going to be 0.4, 2, 4, 6, 8, 10, so it's going to be 0.4 T. So that's your answer for question 20, which is going to be C. So now if we move over to question 21, it asks us, in figure 1, the highest RF value for the amino acids. Okay, so this one you can eyeball it if you want, if we take a quick look at the figure. But so just quickly, the quickest way to do this is it wants us to find leucine and phenylethylamine. So let's just write it down. How about we write solvent S, solvent T for phenylethylamine, phenylalanine, not phenethylene, so phenylalanine, and for leucine. So let's take a quick look. So S, if we take a quick look at the figure, so S for our so phenylalanine is going to be about, it's in between 13, 14, so I would say it's 13.5. Our leucine is going to be, it's about just under it, so it's about 13. Remember, we're measuring it from the center of the blob, so it says that in the stimulus, so in the center. So centimeters, so T is going to be, so in solvent T, remember we're going eastward. So solvent T, it's going to be, phenylalanine is about, I'd say, yep, that looks like 8 centimeters. And then we've got our leucine is about 9 centimeters. So we can tell straight away that it's either going to be our leucine in solvent T, or it's going to be our phenylalanine in solvent S. And it comes down to which one is the bigger number. So 13.5 divided by, remember, in S it's 15. And over here it's 9 divided by 12 in solvent T. So 9 divided by 12 is 75%. And you know that obviously, well, let's say 12 divided by 15 is 80%. So straight away, and if it's 13.5, it's going to be around, I'd say, 90%. So straight away, you know the answer is going to be phenylalanine in solvent S. So the answer, therefore, for question 21 is going to be answer C. Okay, now we can move on to question 22. It asks an amino acid in the figure, which one's going to have the same solvents for S and T? I mean, again, you just have to eyeball it, and you might just have to do some quick maths and quick looking, but we're actually lucky here because question A is the answer and it saves us the trouble of doing every single one. But if you take a look for question A, it's glycine. You can see glycine when you go up from S, if we go upwards, it's going to be 5 centimeters. And if we go, so that's S. If we go for T, it's going to be 4 centimeters. So, and we know 5, it's divided by 15, divided by 12. So they're both 33%. So the answer is straight away, you know, is A. It saves you time in the GAMSAT from doing every single one. So 22 is A. I mean, you can if you wanted to do every single other one, just to double check. But if you're in a GAMSAT, you're not going to do that. In your spare time, you could if you want, just to practice. So if you move to question 23, question 23, this is a nice one. So the figures, it's asking you you have amino acids with the same solvent. RF value is the same for solvent X, but it's different for solvent Y. So if we just draw it quickly, so solvent X and solvent Y, so we're told that solvent X has to be the same. So if solvent X has to be the same, they have to have the same migration north. So that means they all have to say, let's say, have 5 centimeters. So they all have to be here. So they all have to have the same migration. Now, if we're taking a look, it's telling us that they have to have a different RF value for solvent Y, which means that if we tilt our head, remember, it's going this way, they have to have different values for solvent Y. And you can see straight away that it's going to look something like this. So your answer, therefore, has to be D. So 23 is going to be D. Now, we move on to question 24. So the next couple of questions here, or the next few questions, are pretty much trying to test your quick knowledge in if you understand the differences in solvent S and T and I guess the solubility of the amino acids. So 24 is asking you, if you were to mix all those 5 amino acids together, how would you completely separate all 5 of them together? So if you take a look at figure 1, you can see that glycine, serine, tyrosine, alanine, or lysine, they all have similar solvent S, RF values for solvent S. So, but you can see though, if you tilt your head, for solvent T, they all have different solvent T values. So therefore, for question 24, the answer has to be B, because if we just use solvent S, we're going to get similar values. But if we use solvent T, they all have a different solvent RF value in solvent T. So question 24 has to be B. So now if we move on to question 25, I know this is long, it's 7 questions in one unit for the GAMSAT. Oh my God, you're probably just like, oh, it's too much, but we've got to get through. We're almost there. Number 25, it's just a true or false, or pretty much it's asking you, does tyrosine have a greater affinity for solvent S than threonine? So it's tyrosine and threonine. If we take a quick look at the figure, if you turn the page to the figure, you can see tyrosine and threonine. So if we take a look, tyrosine has a greater RF value in S, but threonine has a greater RF value in T. You can see straight away by their migration. So therefore, if we go to question 25, yep. So question 25, comment 2 is incorrect. Tyrosine doesn't have, it's tyrosine threonine. Tyrosine doesn't have a greater affinity for solvent S, solvent T than threonine. If we take a quick look, tyrosine actually has a it has a less migratory pattern in solvent T than it does threonine. So that's incorrect. So the correct only so if we've got for 25s for 1 and 2, comment 1 is correct, comment 2 is incorrect. So therefore the answer has to be for 25, B. So the answer for 25 is going to be B. Yeah, you just have to wrap your head around it. So, because I have to look left and right just to make sure. So just make sure in the GAMSAT you wrap your head around this as well. You don't get confused. So the last question, similar kind of question here. So you've got 3, comment 1, 2, and 3. Are they all correct? Are they all incorrect? What do we have? So it's talking about lysine's affinity for either solvent S, solvent T, or for paper. So let's just look at the graph anyway, without looking at the options. So you can see here that lysine has an RF value for solvent S is going to be about 9. So for solvent S, it's going to be about 9 divided by 15. So it's going to have some affinity for S. It's going to have a good affinity for S. But solvent T, lysine is only about 1 centimeter. So it's got a pretty poor affinity in T, but a good affinity in S. So if we go back here now to the options, so option 1, lysine has a greater affinity for solvent S than for the paper. That's correct. So option 1 correct. Option 2, lysine has a greater affinity for solvent T than for the paper. That's incorrect. We just saw here it doesn't. And number 3, lysine has a greater affinity for solvent S than for solvent T. Yes, that's correct. So we know, therefore, option 1 and 3 are correct. So if we take a look through A, B, C, and D, the correct option is going to be D, so 1 and 3. So that's your answer. Now, look, this was a bit of a slog, but you are going to get these sorts of questions in the GAMSAT. And to answer these quickly, it would have helped if you did have a background knowledge in paper chromatography and how to analyze using RF values and solvents and these sorts of things. So it would have negated you reading the whole thing, reading the whole stimulus. It would have saved you some time. But working through it, it was kind of straightforward. You just had to wrap your head around what you were looking at. And look, if you do have any more questions, you can put them down in the comments below, or you can contact us directly. We'd love to help. Chemistry is our bread and butter, and no question is too difficult for us to help you with. So thanks for your time. Bye now.